Teach me the ways of the soil.
Yeah, this is an interesting one.
Isn't this cool?
This definitely outwashy stuff here.
Okay.
See
Got a little
how,
band of outwash.
yeah, which is not unusual in this stuff. I was looking at the, I don't know exactly, this almost looks like a moraine here. I mean, not like a recessional moraine.
Okay.
But yeah, that's, you see a little more reddish tint in the till.
See if I can zoom this thing in, if it'll let me. No.
And probably a sandy clay loam.
Okay. Excellent. That's what we called it.
Yeah, and this, I don't have very much acid, but
I have some if you need more.
I'm sure I don't see that.
Definitely some reaction there.
And I don't think this outwash will react. See, it won't now.
Okay.
I think it's because it's more permeable. I think everything's been leached out of it and then collected. Of course, this is dense till, I would call it.
Okay.
This
so
is
it's got a band of outwash over dense till.
Yeah.
Cool.
And this one's pretty eroded, because even this is, you know, that was calcareous, which is there's a little. Maybe a little mixing of that outwash on the till at the top.
Is it weird to suggest that there might have been different depositional events here? Is that possible, or is it just?
Well, there probably were, but it was all like in the same advance.
Okay.
Because, I mean, as I look at pits and study soils, this whole process is a lot messier, because you had cracks in the ice.
Okay.
You had, you know, literally rivers on top of the ice.
Okay.
And so there's just a lot more mixing.
Okay.
You know, I think. And you can see, if you follow this band, it almost looks like it dies out.
Like it's a tiny little area.
Yeah.
Yeah, it gets thinner and thinner over here.
Yeah. See, it just kind of disappears. Which is not unusual. So I don't know if that's just
we just happened to find the one tiny little band of it.
Well, I mean, if it's thick enough, this is a soil we call Rawson, which has, you know, outwash over heavy till.
Cool.
So, but see, it almost looks a little thicker over here, but not. But you can see that nice. I mean, that's a little bit reddish tint.
Yep. Especially
when you compare it to the till. I mean, that's a big difference.
Yep.
In color.
Definitely two different parent materials there.
Yeah. Yeah. So.
Awesome.
Yep. Outwash over till. That's what.
Fabulous.
So.
Okay.
Or outwash within the till.
Very interesting findings.
Because here you actually got, you know, till and outwashing back to till.
Yeah.
And I think this is all, I mean, this is a little more weathered.
Okay.
But I think it's all the same.
Okay.
And then this top is a little bit, I'm wondering if there's, it is really, there's a lot of fragments in there.
Yeah.
So I'm wondering if some of this was even
a lot of fragments.
Maybe a little something dumped in here. Or we're down at the base, so might have been a lot of stuff coming out.
Coming down.
But it almost looks a little platey.
Mm-hmm.
It's pretty eroded. I mean, it's
that surface layer is very thin.
It's pretty beat up. Right here, which good dense till. I mean, you don't see many pores, and you don't see, there's not many roots in this at all. But as water moves down through here, you know, this has to become saturated before the water will move into these smaller pores. And then, so sometimes you get lateral movement too, down the slope. But that's Scott's favorite texture, sandy clay loam. He likes that.
You hear that, Scott? We found your favorite.
Doesn't have as much. It's probably so the clay almost kind of dry, but
okay.
Then you see the carbonate coats.
Let me zoom in.
Yeah, see those carbonate coats.
Yeah.
See, there's a little crack in the till.
Yep, and then the seams of them.
Yeah.
Interesting.
And so it's probably, well, combination of geogenic and pedogenic. But,
okay.
I mean, we would call this a CD, but there is a little bit. I mean, there's been some geologic weathering for sure.
Okay.
You know, and some processes going on. So, if you go deep enough, you've seen the unoxidized till, which is gray. So
I think we're gonna see an example of that here in a few minutes.
So this has been oxidized.
Okay.
So
super cool.
has some weathering.
Awesome. All right.
Yeah, this is interesting too. So you got about 8 inches of overwash.
Okay.
Stuff that I think come down off the hill from erosion over the. I think this is the original surface. Nice dark black. That's a mollisol, thick enough.
Beautiful.
And then probably, I'm guessing, somewhat poorly drained. It's not really gray enough underneath there to be poorly drained.
Okay.
Although, man, look at, see that almost looks, like, yeah, I think that's a Crotavina. See that going
That's
down?
beautiful. I'm gonna zoom in on that.
See if I can, yeah, see that, how that dark material.
Yeah. I'm gonna zoom in so I can kind of see. There's a little Crotavina.
Yeah. Huh. Yeah, that's pretty.
That's cool. You can just kind of see it come down right here.
Yep.
Right there.
Yep.
Huh. All right.
Yeah, but you can see how it's lighter. We have more overwash than what we've recognized, but it tells a good story because, I mean, you had erosion up here. So it had to go somewhere. And so you can see how it's a little bit lighter, and the structure is not quite as good in this upper part as it is in the original A.
Super cool. And you can really see the bands from back here. I'm going to try to point it out in the video. There's a little bit of a lag on my phone, but there's the surface, and then here's
that's the
previous surface, and then the subsoil. Awesome.
Yeah, they should be able to pick out topsoil from subsoil on this one.
Yeah, for sure.
Yeah, so we got overwash again. See, for the high school, if they have 20 inches, then they overwash, then they judge it differently.
Okay.
And this is getting close, but not quite. But you know, it's pretty good contrast again. Because see, we're not even. It looks like it's small, all the way to the bottom. Of course, you got almost probably 18 inches of overwash. See the contrast in color.
Drastically different, I would say.
Yeah.
Much darker underneath rather than on top.
Yeah, and see, this feels a little bit more like outwash fabric. It's got more sand. Some rounded pebbles, not real rounded, but yeah, I think this is more outwashy. A little bit of, had a lot more sand in it. Last one, isn't it? We're not that far. Tell you, soil's changing in a hurry.
Oh man, these four pits are so drastically different, and
if they don't learn anything else, they learn that soils are variable and that they can change in a pretty short distance.
Yep.
And normally we can explain why. But this overwash, I mean, you can tell a pretty good story with it. Because I think they can see that pretty clearly. Yeah, because we're right here. The stuff would have shot right down here. That's why it's a little thicker here. And see, we're close. Of course, this ditch has been straightened, but that would have been a natural drainage way. And so typically you get a little bit more outwash stuff along those drainage channels.
That makes sense.
Yeah.
It's almost like the glacial floodplain.
Yeah. If they're big enough, sometimes we call them glacial sluiceways.
Okay.
You know, where you had the outwash coming off as they melted. And then, I mean, because if you get, this is a little more dissected here. That's why it almost looks a little bit like a recessional moraine. I'm not sure exactly where we are. But, you know, if you get up on the ground moraine where it's a little flatter, then your till is going to be a little more consistent.
Okay.
And then, of course, there's a lot of little shallow glacial lakes in that stuff. And so there you get, sometimes you get a little lacustrine over the till.
That makes sense.
Yeah. Yeah.
The settling action of the lakes and those dips.
Yeah.
Yeah, isn't that fun? We had to put a bucket of that sand out.
Yeah, that's, man.
And then off.
Yeah, not much doubt that's out. Some pretty clean stuff even. I mean, there's a little. You can hear the grit.
Yeah, you can.
It's probably a loamy sand. I mean, it's got a little fines in it, but yeah. Pretty cool stuff.
Yeah, this is my favorite pit out of all of them.
Yeah, this is probably all. This is outwash.
Okay.
It's interesting. It's got a little. And sometimes in these, this might be the heaviest part, and it might get lighter all the way down as far as clay.
Okay.
But you can see the natural cracking. And the clay and organic matter moving down. There's another. I think we got another crotamina. See that stuff?
Sweet.
Yeah, a lot of times the outwash is going to be a little bit more orangey. Like,
Okay.
not always, but it's definitely got more sand and not as much clay as the till.
Okay.
You can see it's not. It's shine a little bit. It's probably a clay loam, but it's
Okay.
It's not more than 35%. Nice dark surface. Yeah, but you can see we're down here kind of on that, along that glacial channel, or of course now it's hard to tell because these things are straightened.
Yeah. They ditched them out to improve drainage, lower the water table.
But you can see they get the bottom of the ditch and that stuff, it's gonna.
Yep. It's just gonna come out.
Yeah, it's gonna draw from, I don't know, 200 or 300 feet out in the field underneath. It works essentially like a tile system.
Yeah. You get that lateral subsurface drainage going in that sand layer.
Yep. Yeah, this is a nice variety in a short distance.
Right? I really want to use this for...
I don't know who selected this site, but I don't know.
The ag teacher at Eastbrook High School. Yeah, he's good at finding sites, that's for sure. Gary, let loose the knowledge.
Well, we think a lot of times as the glacier as a big bulldozer, you know, as it plowed through, which it is, because they tell us at Fort Wayne, the geologists, they look at the calcium carbonate equivalent and they can estimate the thickness of the ice.
Wow.
So they're saying at Fort Wayne, the ice was about a mile thick.
Wow.
That's a lot of ice.
That's a lot of ice.
So that's a lot of weight, so it sinks down and it pushes almost right on the bedrock and pushes forward. But you also, the other thing you got going on, it's basically a big conveyor belt.
Yeah.
And it's moving material from Canada and wherever. That's why we get, you know, all of our basement rock in Indiana is sedimentary.
Yep.
And so anything that you see that's not sedimentary was brought in by the glacier.
Okay.
You know, and so it's like a big conveyor belt. And so, like I said, you have rivers on top of the ice, you have rivers in the ice, sub-ice tunnels, cracks in the ice, just a lot of things going on, you know. So it's a kind of messy process.
Sounds like a messy process.